to the next point. We should ensure whatever we say is clear.
That means work is being done. We can see that it is in opposite direction.
Good day, learners. You are welcome to yet another segment of e-learning organized by Kaduna State Government. I am Monday Bakwai, one of your mathematics teachers. I'll be taking you through a topic today, number system. And under a subtopic, converting base 10 numbers to other bases. Converting base 10 numbers to other bases. So as we move ahead, what is number system? Number system is the expression of numbers in different bases. Number system is the expression of numbers in different bases. And then we have types of number bases. We have types of number bases. Number one, we have denary, or you can call it decimal numbers. These are numbers expressed in base 10. They are the natural numbers. All counting numbers are denary, and it is the natural operation we are operating in our counting system. So when we say denary, it simply means base 10. We can equally call it decimal. You should also know it is base 10. Then we have one of the number bases as binary numbers. From the word bi means 2. So binary numbers are numbers expressed in base 2. Binary numbers are numbers expressed in base 2. And I want my learners to realize that when you are dealing with base 2, the highest digit you will get in base 2 is 1. If you are dealing in base 10, the highest digit you will get highest number you will get in base 10 is 9. Then we have octal numbers. Octal numbers are numbers expressed in base 8. So numbers expressed in base 8 are called octal numbers. Then we equally have hexadecimal numbers. Hexadecimal numbers are numbers expressed in base 16. Hexadecimal numbers are numbers expressed in base 16. Now we can equally have base 3 numbers, base 4 numbers, base 5 numbers, and so on and so forth. But for the meantime, we concentrate on these types of number bases. And then next, we look at how to convert base 10 to other bases. So we have converting denary numbers to other bases. The word denary should not confuse you because I have explained is base 10. So we are more or less saying converting base 10 numbers to other bases. Now let's cite examples. Example 1. As we can see on the board, we are expected to convert 137 base 10, 137 base 10 to A, binary, B, octal, C, base 5, D, base 3. The question again, convert 137 denary to A, binary, B, octal, C, base 5, D, base 3. Now let's see the solution. Now question A under number 1. Binary, as I've explained, is base 2. So if you are converting 137 to base 2, you will be dividing 137 by 2 and then be keeping the remainders. You will be dividing 137 by 2 and be keeping your remainders. Now, 2 in 137, we arrange it like this. 2 in 13, the result will be 6. 6 remainder 1, and it becomes 17. And 17 divided by 2, you will have 8. But there will be a remainder of 1. So you put remainder 1. Go ahead to divide by 2 again. 68 divided by 2. 2 in 6, you have 3. 2 in 8, you have 4. And there is no remainder, so we put remainder 0. Subsequently, you move ahead. 2 in 3 is 1. Remainder 1. And that becomes 14 by our divisional procedure. So 17 divided by 2, you have 7. Remainder 0. 2 in 17 is 8. If you multiply 2 by 8, you have 16, so we have remainder 1. Then 2 in 8, the answer is 4. Remainder 0. 2 in 4, the answer is 2. Remainder 0. 2 in 2, the answer is 1. Remainder 0. Finally, 2 in 1 cannot, so you write 0, remainder 1. You observe as you are going downstairs, the division becomes so easy because the number is being broken, reduced to smaller units. So now, 137 to binary number will be equals to, you start from the bottom. Look at the arrow. You start from the bottom. It will now be 1, 0, 0, 0, 1, 0, 0, 1, base 2. Start from the bottom. Many students will always start at the top, and it will be a wrong answer. So you have to know that that arrow is giving you a direction. Start from the bottom upward. So the result becomes 1, 0, 0, 0, 1, 0, 0, 1, base 2. So you have finally converted 137 to base 2 to have 1, 0, 0, 0, 1, 0, 0, 1. You don't read it as the normal writing of numbers. If you are to count this in the normal number, you have about 10,000,001. That is not correct. So you call the digit 1 by 1. So it will be 1, 0, 0, 0, 1, 0, 0, 1, base 2. That task is done. All right, question B. We are to convert 137 to octal number. And octal simply means 8. So we are converting 137 to base 8. Divide 137 by 8. You start with the first digit 1. Not possible, you move to 13. 8 in 13, you will get 1. And 1 times 8 is 8. You'll be left with 5. It becomes 57. So 57 divided by 8, you will have 7. 7 times 8 is 56. You remainder 1. You now move ahead. 17 divided by 8, you'll be having 210. And 2 times 8 is 16. So 17 minus 16, you still have remainder 1. Now 2 divided by 8 is giving you a decimal value. So it cannot. Now you write 0. Remainder the 2. Remainder 2. Now, the final solution will be 137 base 10. Start from the bottom. That arrow is giving you a direction. You start from 211. So the result will be 211 base 8. And student, to take note, this base 8, you have to write it in weight. Because if you write in numbers, you may make a mistake by having 2118 and it changed the value. So you write advisably in weight. So 137 will give you 211 base 8. Don't say 211 because you have changed it automatically to base 10. You have to count the digit 1 by 1, 211 base 8. But if you say 211 base 8, it is not correct. Then move to C. We are converting 137 denarii to base 5. So it means you'll be dividing by 5 now. So 137 by 5, you have 13 by 5 is 2 times, remainder 3. 3 with 7 becomes 37. So 37 divided by 5 is 7, remainder 2. You see why if you don't know multiplication table is a problem. And at times, calculator will never help. It will even delay your work. So the best thing is to master your multiplication table, and it will be as fast as possible. Now look at the next step. 27 divided by 5 is 5 times. And then 5 times 5 in your head, you know is 25. So out of 27, we are left with 2. So remainder 2. Next step is 5 itself divided by 5. And 5 in 5 is 1. It goes exactly without remainder. So remainder 0. And then 5 in 1 is 0 because it's not possible. If you divide it, you have a decimal value, 0.2. We are not after that. We are after whole numbers. So 1 divided by 5 is not possible. You write 0, remainder 1. Finally, your final answer will be 137 base 10 to base 5. Start from the bottom. It will be 1022. 1022 base 5. Don't say 1022 base 5 because you are mixing base 10 and base 5. So we count the digits one by one. So we have 1022 base 5. That's our final answer. Then question D, we are expected to convert 137 to base 3. You'll be dividing by the 3. So 137 by 3, you start with the first digit 1, cannot, you move, it becomes 13. So 13 by 3 is 4, remainder 1, because 4 times 3 is 12. That one becomes 17 with the 7. And then 17 divided by 3 is 5. 5 times 3, 15. Out of 17, remainder 2. So that R is representing remainder. So R represents remainder 2. 3 in 4, 1, remainder 1 becomes 15. So you have 5. In another word, 15 divided by 3, 45 divided by 3 is 15. So remainder 0. 15 now divided by 3 is 5. Remainder 0. 5 divided by 3 is 110. Remainder 2. And then 1 divided by 3 is not possible. It cannot, so it will be 0. Remainder 1. Because if you divide 1 by 3, it will be decimal. 0.333 is even a recurring decimal. We are after whole numbers. So 1 divided by 3, 0, remainder 1. Your final answer will now be from the bottom. That arrow, please, is very, very important. It is giving you a direction. So we have 137 base 10 will be equivalent to 12002 base 3. 1200 base 3. Question 2 now. We are moving to question 2. We are expected to convert 438 base 10. 438 base 10 to A base 4, B base 6, C base 7, D base 9. Question again, convert 438 base 10 to A base 4, B base 6, C base 7, and D base 9. Solution. From A, we have to convert 438 to base 4. Just like the first question, you subsequently divide by the given base. So base 4, you divide 438 by 4. 4 in 4, you have 1. 4 in 3, cannot, you write 0. It becomes 38. So now 38 divided by 4 is 9. And then 9 times 4 is 36. So out of 38, we have remainder 2. Move again, 109 divided by 4. 4 in 10, 2. 4 in 29, 7. And 4 times 7 is 28. So remainder 1. 27 now divided by 4 will be 6 times. And 6 times 4 is 24. Now remainder 3. Because 27 minus 24, you'll be having 3 as your remainder. Next, we will divide 6 by 4. And 6 by 4 is 1 time. 1, remainder 2. Finally, 1 divided by 4, we'll be having 0, remainder 1. So if you start from the bottom, you will now have 438 base 10 equals to 1, 2, 3, 1, 2 base 4. 1, 2, 3, 1, 2 base 4. That gives you your final answer. B, base 6. 438 by 6, 43 by 6 is 7. Multiply 7 by 6, you have 42. You are left with 1. And then becomes 18. 18 now divided by 6 is 3, remainder 0. 73 divided by 6, you have 12 times. And 12 times 6 is 72. So 73 minus 72, you'll be left with 1. So remainder 1. 12 now divided by 6, the result is 2. 12 divided by 6, the result is 2, because 2 times 6 is 12. So remainder 0. Now 2 divided by 6 is 0, remainder 2. 2 divided by 6 is 0, remainder 2. So finally, 438 in base 10 will be equivalent to 2010 base 6. 2010 base 6. Then question C, we are converting 438 base 10 to base 7. 438 base 10 to base 7. 7 in 43 is 6 times. And 6 times 7 is 42. So you are left with 1. It becomes 18. 18 divided by 7 is 2 times. 2 times 7, 14. Out of 18, you are left with 4. So remainder 4. 62 divided by 7 is 8 times. 62 divided by 7 is 8 times. And then 8 times 7 is 56. 8 times 7, 56. Then subtract 56 from 62, you'll be left with 6 as your remainder. 8 now divided by 7 is 1. 8 divided by 7 is 1. Remainder 1. Finally, 1 divided by 7 is 0. Remainder 1. So the final result will be 438 base 10 will be equivalent to 1164. 1164 base 7. 1164 base 7. Then we move to the last question D. We are converting 438 base 10 to base 9. 43 divided by 9, you will be having 4. And 4 times 9 is 36. So you'll be left with 68. 68 now divided by 9 is 8 times. 68 divided by 9 is 8 times. Now you have 8 times 9, you'll be having 72. Then you'll be left with 6 as your remainder. You'll be left with 6 as your remainder. Now 48, the next divided by 9. You ask yourself how many times 9 will go in 48 is 5 times. Multiply 9 by 5 is 45. So out of 48, remove 45, remainder 3. You'll be left with 3 as your remainder. Then finally 5 divided by 9. 5 divided by 9 is not possible. It will be a decimal value as I've mentioned. So we are dealing with whole numbers. So 0, remainder 5. I repeat the question again. 439 divided by 9. You start with 4 by 9 is not possible. It becomes 43. So 43 divided by 9 is 4 times. If you multiply 4 by 9, you have 36. Out of 43, you'll be left with 68. Then 78. 9 into 78, you'll be having 8. And 9 times 8 is 72. So remainder 6. So it is involving division, multiplication, subtraction. So 48 now divided by 9, you'll be having 5 times, because 5 times 9 is 45. So out of 48, you'll be having 3 as your remainder left. So 48 divided by 9 is 5, remainder 3. Finally now 5 divided by 9 is not possible. You'll be having a decimal value, and we are not after decimal in this case. So 5 divided by 9 is 0, remainder 5. Therefore, the final result, 438, to convert to base 9, will be equivalent to, start from the bottom as the arrow directed, 536. 536 base 9. 536 base 9. Now, my dear student, learners, you should take note that from all my explanation, you cannot solve these problems without multiplication table. So you must master your multiplication table, your division, your subtraction, and even all the mathematical operation. Now, before I leave you, I have an assignment for you. The assignment is question 1. Convert 193 base 10 to A, binary, B, octal, C, base 5, D, base 3. From the beginning, I said binary is base 2. You should take note. Octal is base 8. You should take note. And then we have question 2. We are to convert 375 base 10 to A, base 4, B, base 6, C, base 7, D, base 9. I want to explain something. 375 base 10, you mustn't put the 10, because it is a natural numbers we are operating. So if you don't put the 10, it's still correct. But for clarity, we put the 10. So you are converting to base 4. But when you convert to base 4, you must indicate base 4. Otherwise, you'll be wrong. So you convert 375 base 10 to A, base 4, B, base 5, C, base 7, and then finally D, base 9. Now, our textual materials, we have 1, New General Mathematics for Senior Secondary School, Book 1 and 3. Book 1 and 3. And then we have question and answers, Q&A, WAEC incline. Then we equally have another textual material, Comprehensive Mathematics for Senior Secondary Schools. Comprehensive Mathematics for Senior Secondary Schools. I remain Monday Bokwe. If you have a problem or when you solve your question, you can send by contacting me through my phone number 080-2525-9755. 080-2525-9755. Stay safe and keep learning. God bless you.